In this next lesson in our probability unit, we are going to look at theoretical probability. The objective of the lesson is to be able to determine the probability of an event and express it as a percent, a fraction, and a decimal. When we talk about probability, we are referring to the likelihood or the chance of a possible outcome happening compared to the sample space. And again, probabilities are typically written as percents, decimals, or fractions. The likelihood of an event can be placed on a scale from 0 to 1. An event with the likelihood of 0 is labeled as impossible, whereas an event with the likelihood of 1 is labeled as certain. And in between those two, we have different benchmarks like very unlikely, unlikely, an even chance. Sometimes you'll hear as likely to happen as not likely to happen. That's where that 50% falls in, to likely and very likely. Since probability is a comparison, it can be found using a ratio written as a fraction. So if we think of our numerator, this would be the number of favorable outcomes, and our denominator would be our sample space. For example, if I wanted to find the probability of rolling a 1 on a 6-sided dice, I first think about it being a ratio. So I put in my fraction bar. In math, we often express probability with the letter P, and then in parentheses, we put what we're looking for, or our favorable outcome. In this case, we're wanting to roll a 1. So from our previous video, you learned about listing the possible outcomes and determining the sample space. When I roll a 6-sided die, 6 things could happen. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. The favorable outcome I want is the 1. So I have 1 favorable outcome, and my sample space is 6. So the probability of rolling a 1 is a 1 out of 6 chance. If I want to express that as a decimal, I take the numerator and I divide it by the denominator, and I get roughly 167 thousandths. Changing that to a percent, I move the decimal 2 places to the right, which is the same as multiplying by 100, because percent is out of 100. And the probability of rolling a 1 is a 16.7% chance. If we think about this on the likelihood scale, it's very unlikely I would roll a 1. Let's look at another example using that same 6-sided die. What's the probability of rolling an even number? So again, I express that as the letter P, and in parentheses, the favorable outcome of an even number. Again, it's a ratio, so I put in my fraction line. Here are my possible outcomes. And when I look at my favorable outcome, I'm looking for just the even numbers. So a 2 is an even number, a 4 is an even number, 6 is an even number. So I have 3 favorable outcomes. My sample space has remained the same. I have 6 possible outcomes when I roll that die. So I have a 3 out of 6 chance of rolling an even number. I can reduce that to the fraction 1 out of 2, which we know if we divide the numerator by the denominator is 5/10 or 50 hundredths. And as a percent, that's 50%. So on that likelihood scale, I have an even chance of rolling an even number as I do an odd number. Now here's one for you to try. I want you to sketch this spinner in your notebook, and then I want you to calculate the probability of spinning an odd number. So probability P, parentheses, odd number. Pause the video while you're working this problem, and then press play when you're ready to check your work. You learned in the previous video that a tree diagram can be used to find the sample space, but it can also be used to calculate probability. So I've used that same example we used in the previous video about flipping a coin 2 times, and I've just copied over our tree diagram from that work. I want to calculate the probability of flipping at least 1 heads. So P, parentheses, at least 1 heads. So if I start thinking about just this first flip, there are 2 possible outcomes, heads and tails. Heads is 1 out of those 2, or 1/2, and tails is 1 out of 2 outcomes, or 1/2. Now, if I consider my second flip, heads is still 1 out of 2 things that can happen on my second flip, and tails is 1 out of 2 things that can happen on my second flip. Same for this second branch of my tree diagram. Now, if I'm wanting to calculate each of the probabilities for these outcomes, I need to think about multiplying the probability in my first flip by the probability of my second flip. So 1/2 times 1/2 will equal 1/4. And since all of the probabilities are 1/2, each of these outcomes will have a 1 out of 4 chance of happening. Now, when I look at my favorable outcomes, it's at least 1 heads. So heads has at least 1 heads. Heads tails has at least 1 heads. And tails heads has at least 1 heads. Tails would not be a favorable outcome because it does not have at least 1 heads. To finally calculate the probability, I just need to add the fractions, or the probabilities, of each of those favorable outcomes. 1/4 plus 1/4 plus 1/4 is 3/4. I have a 3 out of 4 chance of flipping a coin twice and getting at least 1 heads. Changing that to a decimal, I have 75 hundredths, or 75%. So I have a pretty likely chance of getting at least 1 heads if I were to flip a coin 2 times. Now I have one for you to try. I first want you to make a tree diagram of rolling a die and flipping a coin. Then use that tree diagram to find the probability of flipping heads with an even number. Press pause while you're working this problem, and then press play when you're ready to check your work. In this video, we learned how to determine the probability of an event as a percent, fraction, and decimal. Until next time.